Hi everyone, I am Diveshi from ISC department, BTech second year from GM University. Today I am explaining the course of operating system guided by the Shivana Gowda sir. Our course code is UE23CS2306. Our team name is Visionary. Our team members are Saraswati from ISC department and Pratibhavati from ISC department and Kusma from ISC department. Let's come to our topic is basic process termination. Basic process termination in an operating system occurs when a process completes its task or terminated by the OS. The OS releases allocated to the process, updates the process table and may pass on exit status to the parent process. After termination, the process is removed from the system, ensuring efficient resource management. And next is continued by the Pratibhavati.
I am Pratibhavati. I am going to explain the code. Here is the code. Import OS import time. It imports the OS for process related functions and time to add delays. Define span child. It defines the function responsible for creating child process. While true, creates an infinite loop to continuously span processes. Process ID is equal to OS dot fork function. It creates a child process. It returns 0 in the child process and child process ID in the parent's process. If process ID is equal to 0, it checks if it is in the child process. Printf. It prints the child's process ID and its parent's process ID. Time dot sleep of 1. It pauses for 1 second to observe the creation. Span child. Recursively calls itself, creating more child processes. Else handles the parent's process. OS dot wait process waits for a child process to terminate. It is optional. If name is equal to main, runs the code only if the script is executed directly. Try starts infinite process creation. Except keyboard interrupt. Gracefully handles user interruption. Except exception ASE. Catches and prints other exception. Here is the output. Child process 5627 created by parent 5626. It will continue. Next will continue by Saraswati.
Here there is a code which I am explaining. Hash include stdio.h, hash include stdlibrary.h, hash include unistd.h. This is the library functions. Void span child define a functions called span child to span child process in a loop. While start an infinite loop keeps creating child process. Process ID underscore t, process ID is equal to fork. Calls fork which create a child process. Process ID stores the result equal to 0 for the child and the child process ID for the parents. If process ID is lesser than 0, check if fork fails. Fork fails, print an error message if fork failed. Exit the program if fork fails. Else if process ID equal to 0, check if the child process. Print child process panel with process ID, print parents process ID, get process ID, print the process ID of the child and its parent process ID. Sleep. Pause the child process for 1 second before continuing. Else, parent process block. If PID is not 0, it's the parents. Wait null. Wait for the child process for finishing. Close the infinite loop for swapping child inside the swap child. Int main function of the program. Print start infinite child process span parents process ID, get process ID, print the main process ID, when the program starts. While start an infinite loop in the main function. Process ID underscore t, process ID equal to fork. Fork to create a new child process. If process ID is lesser than 0, check if fork is failed. Fork is failed, prints an error message is fork failed. Check. Exit. Exit the program if fork failed. Else if process ID equal to 0, check if it is the child process. Prints child process panel with a process ID, parents process ID, get process ID, get process ID. Print the child process ID and its parents process ID. Span child. Call the span child function, which recursively span more child process. Else, parents pros block. Sleep. Pause the parent process for 1 second. Close the infinite loop for the main function. Return 0. Return function of the main function through an unwanted reach the line before because for the infinite loop. Next will be continued by the Kusma.
Dear Kusuma, here there is a conclusion. Both programs demonstrate recursive process creation using OS4. While they effectively showcase the ability to create and manage process in Python, they are highly risked due to infinite recursion, leading to uncontrolled process spanning. This behavior can quickly exhaust system resource, potentially crashing the system. These programs should only be run in a